The ocean covers 71% of this planet, and humans have mapped less of it than the surface of Mars. But there are specific zones so deep, so pressurized, and so structurally strange that even our most advanced submarines have never physically reached them. And what sonar has bounced back from a few of them doesn't match anything in the geological record. Start at number 10, and already the ocean is doing something it shouldn't be able to do. Number 10. The Hadal Scatter Layer. Below roughly 16,000 feet, sonar operators have documented what researchers call a false bottom, a dense layer of biological and particulate matter so tightly packed that it returns a signal almost identical to solid sea floor. Ships crossing certain deep Pacific trenches have logged this layer for decades, occasionally watching it migrate vertically overnight by hundreds of feet. No submarine has physically descended through it to document what lives inside that column, because the pressure at that depth already exceeds what most crewed vessels are rated to survive. What sonar can't tell you is whether the layer is moving because of current, because of something feeding inside it, or because of a mechanism no one has named yet. The geological record has no clean explanation for why it concentrates where it does, clustered near specific trench walls rather than spread evenly across the basin floor. That asymmetry is the part researchers quietly flag and then move on from, because there's no instrument small enough, durable enough, and pressure-rated enough to go inside and look. Number 9. The subcrustal voids beneath the Mariana Arc. Seismic surveys of the Western Pacific have returned something stranger than the trench itself. Beneath the Mariana Arc, the volcanic chain that flanks the deepest point on the planet, geophysical imaging has identified large low-velocity zones sitting below the ocean floor, inside the crust. Low-velocity zones mean the rock there is behaving like something partially molten, or hollow, or structurally inconsistent in a way that standard plate models don't predict for that location. These aren't small anomalies. Some of the mapped zones span areas comparable in footprint to a mid-sized country. No drill has reached them. No submarine could. They're inside the rock itself, not in open water. What they contain, whether superheated fluid, gas, or something the models haven't accounted for, is genuinely unknown. The deeper question isn't what's down there. It's why the crust in that specific region behaves differently from every comparable arc system on Earth. No one has a clean answer for that either. Number 8. The Hadal Interstitial Channels. But the subcrustal voids beneath the Mariana Arc aren't the only place the ocean is hiding something inside solid matter. 3 zones down from where we started, the mystery moves laterally, through the trench walls themselves. Seismic mapping of several deep Hadal trenches, not just the Mariana, but comparable formations in the Tonga and Kermadec systems, has revealed what geophysicists describe as interstitial channel networks running horizontally through the trench walls at extreme depth. These aren't cracks in the conventional sense. They appear in imaging as organized, branching structures, more consistent with fluid-carved passages than with random fracture patterns from tectonic stress. The channels sit at depths where no crewed submarine has ever operated, and no remotely operated vehicle has been rated to navigate laterally inside a trench wall. So the imaging is all we have. What the channels carry? Superheated brine, microbial colonies operating on chemosynthetic cycles, or pressurized gas migrating upward from the mantle, remains entirely open. What makes them anomalous is the branching geometry. Random fracture doesn't branch with that kind of regularity. Something shaped those passages, whether that something is fluid dynamics operating over millions of years or a process geologists haven't fully modeled yet, is the question no one can answer from the surface. The trench walls, it turns out, may be less like solid barriers and more like circulatory systems. That reframing alone changes what the deep ocean floor actually is. Number 7. The Abyssal Plain Dead Zones. Spread across the deepest flat regions of the Pacific and Atlantic basins are areas sonar has returned almost nothing from. Not silence in the way an empty room is silent, but silence in the way a signal-absorbing material is silent. Researchers studying these abyssal plain sectors have noted that acoustic returns from certain coordinates are anomalously low, as though the seafloor in those patches is composed of material with unusual density or porosity compared to surrounding sediment. Some of these zones extend for hundreds of miles without a single feature. No ridge, no vent, no biological signal. That absence is itself the anomaly. Everywhere else at comparable depth, life finds a way into the sediment. Here, the sediment appears to return nothing at all. Whether that reflects a chemical environment hostile to all known biology, a geological composition that simply absorbs rather than reflects, or something the instruments aren't calibrated to detect is, at this point, genuinely unresolved. The ocean doesn't have to hide something extraordinary to be unsettling. Sometimes the most disturbing answer is a flat, featureless nothing, stretching farther than you can imagine and completely unexplained. Those abyssal plain dead zones, hundreds of miles of seafloor returning absolutely nothing, which unsettles you more. The trench walls that branch like circulatory systems, or the flat zones where even biology goes silent. Drop your answer in the comments below. Now, we're going deeper, and the next 5 entries are where the sonar data stops making sense entirely. Number 6. The thermal inversion corridors. But the dead zones aren't the strangest silence the deep ocean produces. 5 entries into this list, the anomalies stop being about what's absent and start being about what's moving when nothing should be. In several deep basins across the Indian and South Pacific Oceans, oceanographic survey vessels have recorded thermal inversion corridors, columns of water where temperature increases with depth rather than decreasing, in patterns that violate the basic thermodynamic behavior every ocean model is built on. Standard physics says cold water sinks, warm water rises. In these corridors, something is pushing heat upward from below with enough consistency that the inversion holds across multiple survey passes, sometimes years apart. The corridors are narrow, some measured in hundreds of meters across, which is part of why they've stayed under-discussed. They don't show up clearly in wide-area satellite thermal mapping. You have to be directly above one, dropping instruments through the water column to catch the signal. No submarine has descended the full length of one, because the pressure at the base of these corridors sits at depths that exceed operational limits for all currently rated crewed vehicles. What's generating sustained upward heat transfer through kilometers of ocean at those coordinates, without a mapped hydrothermal vent system directly beneath, is an open question. Some researchers have proposed unmapped mantle activity. Others have noted the corridors cluster near ancient subduction boundaries in ways that don't align with current tectonic models. Neither explanation closes the gap cleanly. Something below those corridors is running warm. The ocean just won't let us get close enough to find out why. Number 5. The deep scattering boundary discontinuities. Halfway through this list, and the pattern is becoming harder to ignore. Every zone we've covered shares one feature. The data returns something, but not enough to explain it. Number 5 is where that pattern sharpens into something almost deliberate looking. In multiple locations across the deep North Atlantic and Western Pacific, sonar surveys have identified what researchers term boundary discontinuities. Precise horizontal planes inside the water column where acoustic behavior changes abruptly, as though the water above and below the line are operating as 2 completely separate physical environments. The transition isn't gradual, it's a hard edge. Instruments dropped through it register immediate, sharp changes in density, salinity, and acoustic velocity simultaneously. Not the slow gradient a normal thermocline produces, but a near-instantaneous shift that some survey logs have described as crossing a membrane. What maintains that boundary with such precision, across coordinates spanning hundreds of miles, without a visible physical structure holding it in place, is something current fluid dynamics models treat as theoretically possible, but have never fully explained in the field. The ocean, it turns out, has internal walls, and no one built them. Number 4. The polar abyssal gyres. Those internal walls the ocean built without anyone's help aren't the last structural impossibility on this list. 2 entries from the halfway point, the anomaly shifts from the tropics to the poles, and from something stationary to something that moves in a closed loop no model predicted. In both the Arctic and Antarctic basins, deep current surveys have identified what oceanographers describe as abyssal gyres, rotating bodies of water operating at extreme depth, below the reach of wind-driven surface circulation, spinning in patterns that should, by every conventional model, have dissipated against the seafloor friction over geological time. They haven't. Some of these gyres appear in survey data taken decades apart, still rotating, still coherent, still occupying the same coordinates. The water inside them is measurably distinct from the surrounding basin. Different temperature profiles, different salinity gradients, different dissolved oxygen concentrations, as though the gyre has been maintaining a sealed internal environment for a period far longer than fluid dynamics comfortably accounts for. No crewed submarine has descended into the core of one. The depth alone prohibits it, and the rotational shear at the boundary layer presents an additional structural hazard that no current vehicle is rated to cross. What's sustaining the rotation, whether residual energy from ancient tectonic events, density differentials no surface survey has fully mapped, or a mechanism the models simply haven't incorporated, remains genuinely open. What's inside the sealed water column at the gyre's center, undisturbed and chemically isolated for potentially millions of years, is a question no instrument has yet been positioned to answer. The poles, it turns out, may be running the ocean's oldest uninterrupted experiments. We just haven't been invited to observe them. Number 3. The mesopelagic pressure inversion zones. One entry from the top 3, and the pattern that's been building across every zone on this list arrives at its sharpest point yet. Everything above number 3 involved anomalies at the extreme floor of the ocean. Number 3 sits in the middle of the water column, and that's precisely what makes it the most disorienting entry so far. In multiple ocean basins, pressure readings taken during deep instrument deployments have returned values that don't correspond to the depth at which the instruments were operating. Not instrument error, the readings have been cross-verified across independent deployments in different basins using different equipment. The pressure at certain mesopelagic coordinates registers higher than the water column above it should physically produce. The discrepancy is small in absolute terms, but in a domain where pressure is one of the most predictable variables in all of oceanography. Any deviation that repeats across independent measurements is, by definition, unexplained. Researchers have proposed localized density anomalies, unmapped subsurface current interactions, and instrument calibration drift. But none of those explanations have been confirmed with follow-up data, partly because the zones are difficult to relocate precisely, and partly because no sustained instrument platform has been stationed inside one long enough to rule the candidates out. The deep ocean has always been defined by pressure. The fact that the pressure itself is behaving unexpectedly in the middle of the water column before we've even reached the floor suggests the list of things we don't understand isn't shrinking. It's deepening. Number 2. The benthic boundary fluid reservoirs. One step from the top of this list, and the anomaly that's been building across every zone, the pressure that misbehaves, the walls the ocean built itself, the gyre spinning in sealed loops for longer than models allow, converges on a single, deeply uncomfortable finding at the seafloor interface itself. In multiple deep basins, sediment-penetrating instruments have returned evidence of what geophysicists describe as fluid reservoirs sitting just beneath the benthic boundary layer, the thin zone where the water column meets the ocean floor. These aren't hydrothermal systems. They don't produce the heat signatures or chemical plumes associated with known vent activity. They appear in imaging as pressurized pockets of fluid, chemically distinct from both the overlying seawater and the surrounding sediment matrix, sitting in structural positions that suggest they've been sealed and isolated for an extraordinarily long time. Some of the mapped reservoirs span areas larger than several major cities combined. None have been directly sampled. The depth prohibits crewed access, and the sediment layer above them is too mechanically unstable at that pressure for conventional drilling to penetrate without risk of catastrophic blowout. What the fluid contains, ancient seawater chemically frozen in a pre-industrial ocean state, microbial communities operating on metabolic timescales measured in centuries, dissolved gases under pressures that would behave unpredictably on contact with the water column above, is entirely speculative. What isn't speculative is that the reservoirs are there, that they're chemically anomalous, and that every attempt to model how long they've been sealed produces numbers that make geologists visibly uncomfortable. The ocean floor isn't a floor, it's a lid. Number 1. The full-depth Hadal unsampled core zones. And then there is number 1. The zones that don't just resist our instruments, they resist our categories entirely. At the absolute deepest points of the Mariana, Tonga, and Philippine trenches, below every depth any crewed or uncrewed vehicle has physically reached and returned from intact, seismic and acoustic data have consistently identified regions where the returning signal simply stops conforming to any known geological or hydrological model. Not anomalous readings, not unexpected values. The signal returns data that existing frameworks have no classification for, patterns that don't match open water, don't match sediment, don't match rock, and don't match any biological acoustic signature in the literature. Researchers who have reviewed these returns have described them in published survey notes with language that is unusual for scientific documentation, structurally inconsistent, classification pending, outside current modeling parameters. That last phrase is the one that matters. Outside current modeling parameters doesn't mean the instruments broke. It means what they detected doesn't have a name yet. No vehicle rated for those depths has ever been built and successfully recovered. The engineering required to survive full Hadal pressure at those coordinates, somewhere beyond 35,000 feet, in near-complete darkness, under pressures exceeding 1,000 atmospheres, remains beyond what any program has publicly achieved. So, the data sits, reviewed, flagged, and filed under a category that translates in plain language to, we don't know what this is. 71% of the planet, less mapped than Mars, and at its deepest points, returning signals that don't fit any model we've built. The ocean isn't keeping secrets because it's trying to. It's keeping them because we haven't built the tools to take them yet, and in every zone on this list, the gap between what we've detected and what we can explain is not closing. It's widening. Subscribe if you want more like this, and watch the next one on screen.